Not too long ago, before the age of antibiotics, a simple infection could mean a death sentence. Minor wounds, persistent coughs, or poorly assisted childbirths often led to sepsis and the end of life. Medicine, despite its progress, was still powerless against the invisible force of bacteria. Hospitals were full, and antibiotics didn't exist. Thousands died from diseases that today can be cured with a single pill. It was a world where life was fragile, and chance, or luck, played a cruel role in the fate of millions. But in 1928, in a modest laboratory at St. Mary's Hospital in London, something extraordinary happened. A seemingly ruined experiment led to an accidental, yet revolutionary, discovery. The name behind this historic moment, Alexander Fleming. Fleming wasn't a flashy scientist. He was discreet, methodical, almost invisible among the great names of British science. But he had a rare quality, a sharp eye, sensitive to details that many overlooked. It was this attention to the seemingly mundane that led him to identify the hidden power of a simple mold. What he discovered wasn't just a substance, it was a turning point. Penicillin, a fungus with natural antibiotic properties, would become the key to unlocking the doors of modern medicine. For the first time, humanity had an effective weapon against deadly infections. Fleming wasn't seeking fame, but his name would echo across the world. Although other scientists were crucial to the development and mass production of penicillin, he would be remembered as the man who saw salvation where others saw only a lab mistake. This video isn't just about a scientific discovery. It's about persistence, humility, vision, and above all, humanity. It's the story of a man who, by not ignoring a stroke of luck, helped write a new chapter in medical history. Get ready to meet Alexander Fleming, the Scottish doctor who changed the world with a forgotten petri dish. His life, marked by simplicity and brilliance, reminds us that the greatest revolutions can begin in the smallest details. Alexander Fleming was born on August 6, 1881, on a farm called Lockfield, near the small village of Darvel in Scotland. He was the seventh of 8 children in a modest family. His father, Hugh Fleming, was an elderly farmer when Alexander was born, and his mother, Grace, was a strong and practical woman, devoted to the home and the education of her children. Life in the countryside was tough and simple. From an early age, Alexander learned the value of silence, observation, and patient work. Surrounded by nature, he developed a keen sense of curiosity. The world of plants, animals, and small natural transformations fascinated him. At the local primary school, Fleming proved to be a dedicated student. Though quiet, he wasn't the type to stand out with speeches or grand gestures, but his mind was active and analytical. His teachers saw him as a young man with great potential, yet in no rush to show off. After his father's death, when Fleming was only 7, the family faced even greater financial hardship. Despite this, his mother insisted that the children receive a formal education. That persistence was crucial for Alexander's future. At the age of 13, he moved to London to live with an older brother. He worked as a clerk at a shipping company and later excelled in his studies at the Royal Polytechnic Institution. It was there that his talent for science began to take shape. But science was not his initial career interest. Influenced by his brother, who was a doctor, Fleming decided to enroll at the London School of Medicine at St. Mary's Hospital. At first, the choice was more practical than passionate. There was a scholarship available for medical students, and he needed to work to support himself. However, the clinical environment soon awakened his true interest. Alongside his medical studies, he dove into bacteriology, a still young field full of possibilities. His attention to detail and disciplined nature made him a standout student and a promising researcher. In his youth, Fleming did not seem destined for fame. He was calm, soft-spoken, and showed no trace of vanity. But within him was a mind prepared to see the invisible, someone ready to make history, even if he didn't know it yet. After completing his medical studies with distinction, Alexander Fleming joined the inoculation laboratory at St. Mary's Hospital as a researcher. There, he had the opportunity to work alongside Almroth Wright, one of the pioneers in research on immunization and bacterial resistance, a key figure in Fleming's scientific development. Wright was an eccentric scientist, full of bold ideas, who deeply believed in the body's natural immunity. He encouraged rigorous observation and constant experimentation, values that Fleming absorbed and carried with him throughout his entire career. In the lab, Fleming wasn't seeking recognition, nor did he follow the scientific trends of the time. His style was methodical, almost obsessive, and he preferred to work in silence, devoting hours to meticulous experiments. He was the kind of scientist who let results speak for themselves. His first major contribution came with the discovery of the enzyme lysozyme in 1922. While analyzing a contaminated sample of human mucus, he noticed it naturally destroyed bacteria. It was an important discovery, For the first time, it was proven that the human body possessed an effective antibacterial substance. Despite its scientific significance, the discovery of lysozyme had little impact at the time. Many colleagues considered it just a biological curiosity, and Fleming, as usual, made no fuss about it. But this episode revealed something essential: his attention to phenomena others ignored. He believed the greatest discoveries came from simple questions. Why do some people get sick more than others? How does the body react to invading microorganisms? And most importantly, how could we use those natural reactions to our advantage? Meanwhile, early 20th century medical science was still fumbling in the dark when it came to infections. Treatments were often aggressive, ineffective, or even dangerous. Fleming knew something safer and more effective had to be found, and he kept searching in his lab for clues that could point in a new direction. It was this persistent curiosity, nurtured by years of quiet practice, that prepared Fleming for the decisive moment of his life, a moment that, like so many of his discoveries, would come not from a brilliant plan, but by chance, seen through trained eyes. It was late September 1928. Alexander Fleming had just returned from vacation and, as usual, headed to his laboratory at St. Mary's Hospital. On the workbench were several Staphylococcus culture plates he had left before leaving. Most were covered with bacterial colonies, but one stood out. On that specific plate, something unusual had happened. A small, clear circle where no bacteria had grown. In the center, a greenish mold was quietly spreading. Most scientists would have dismissed it as contamination. Fleming, however, paused, looked closely, and began to investigate. The mold was identified as Penicillium notatum. More than that, the substance it produced seemed to inhibit the growth of dangerous bacteria. It was extraordinary. One microscopic organism fighting another, a natural weapon against infection. Fleming named the substance penicillin. He spent the following months testing its effects on various types of bacteria, including some of the most resistant strains. The results were promising. Penicillin appeared to selectively target harmful microorganisms without harming human cells. Despite the importance of the discovery, there was a problem. Penicillin was unstable, difficult to isolate, and hard to produce in large quantities. Fleming, who was not a chemist, didn't have the resources or technical expertise to solve this issue. Still, he published his findings in 1929 in a modest scientific article that went largely unnoticed. For years afterward, penicillin lay dormant in the archives of science. Fleming continued his research but never gave up the belief that he had found something of immense value. His colleagues, however, saw it as a vague promise, interesting but impractical. It wasn't until the 1940s that the real revolution began, when scientists Howard Florey and Ernst Boris Chain at the University of Oxford revived Fleming's work. They succeeded in purifying and mass-producing penicillin, turning that accidental observation into a real-world medicine. But the credit for the discovery, for looking past the mess of the lab and seeing a scientific miracle, belonged to Fleming. Without his curiosity, patience, and attention to detail, the mold on that plate would have been just that, mold. In his hands, it became the greatest medical discovery of the 20th century. Despite the clear importance of penicillin, Fleming's discovery was initially met with little enthusiasm. The substance was unstable, difficult to purify, and virtually impossible to produce in large quantities with the resources available at the time. It was like finding gold dust but with no way to mine it. Fleming tried, with his limited means, to extract and stabilize penicillin, but the chemical methods required were beyond his training and laboratory capabilities. He even tested it in a few clinical cases with promising results, but couldn't go beyond small experimental applications. The scientific community, aside from a few attentive minds, didn't give the discovery the attention it deserved. Without fanfare, and without strong clinical results, penicillin nearly faded into obscurity. It would take more than 10 years before someone took up his research seriously. That revival came in 1939, with Howard Florey and Ernst Boris Chain at the University of Oxford. They rediscovered Fleming's old papers and, facing the looming threat of World War II, recognized the potential of the substance against the infections ravaging the battlefields. With a multidisciplinary team, Florey and Chain succeeded in isolating the active ingredient of penicillin in a purified form. They tested it successfully on mice and soon after on humans. The results were spectacular. Infections that were once fatal began to recede in the face of the new antibiotic. The next challenge was scaling up production. Penicillin was being produced in tiny amounts by fungi grown in makeshift labs, a slow and expensive process. With support from the U.S. government, industrial experiments began. eventually leading to the development of large-scale fermentation techniques. Mass production became a reality just as World War II reached its peak. Thousands of wounded soldiers were saved thanks to penicillin. What had once been a laboratory experiment became a crucial resource in the war effort and a symbol of hope for humanity. Fleming watched it all unfold with humility. He knew that without the work of Florey, Chain, and many others, his discovery would have been left behind. But he also knew that without his careful eye and open mind to chance, none of it would have existed. Penicillin had won the greatest battle of all, the battle between life and death. With the success of penicillin on the battlefields and in civilian hospitals, Alexander Fleming's name finally gained worldwide recognition. From an almost unknown scientist, he became celebrated as the man who had given humanity its first effective weapon against bacterial infections. In 1945, Fleming received the Nobel Prize in Physiology or Medicine, along with Howard Florey and Ernst Boris Chain. The choice was both symbolic and fair. It acknowledged each one's role in the cycle of discovery, development, and application of penicillin. Fleming, as always, accepted the honor with simplicity and humility. Even with his newfound fame, he never abandoned his reserved nature. He continued working at St. Mary's Hospital, teaching, researching, and maintaining his quiet routine. It was common to see him walking through the halls as if nothing had changed. Same white lab coat, same focused expression. From that point on, his greatest concern was warning against the indiscriminate use of penicillin. He foresaw, with surprising clarity, that misuse of the antibiotic could lead to bacterial resistance. In lectures and interviews, he emphasized that this miracle drug had to be used responsibly. The impact of penicillin was immeasurable. It's estimated that millions of lives have been saved since its introduction. The discovery paved the way for a new era of medicine, in which other classes of antibiotics were developed, completely transforming the treatment of infectious diseases. Fleming became an admired figure around the world. He was honored by kings and presidents, knighted by the British Crown, awarded honorary doctorates, and saw his name forever etched into the history of science. But above all, he was remembered as the scientist who didn't overlook a chance event. He died in 1955 at the age of 73, leaving behind a legacy that lives on in every bottle of antibiotics, in every patient cured, in every healthcare worker fighting infections. His simple life, marked by hard work and a keen eye, became a symbol of hope. Today, when we speak of Alexander Fleming, we're not just talking about a name in science books. We're talking about a decisive moment in human history, a moment when chance met the right mind and forever changed the course of modern medicine.